Hello everyone, I'm Leonardo Pavanato from Virginia Tech, and today I will talk a bit about our work on evaluating augmented reality virtual monitors for productivity work. This work is a partnership between Virginia Tech and Microsoft Research. While the value of multiple large physical monitors is well established for productivity work, the context of an increasingly work from home world introduces some impediments to productivity, such as the limited number of monitors, the need for physical space to set the devices, and the lack of portability. Our objective was to investigate the effects of replacing or extending physical monitors with virtual ones for productivity tasks. The concept behind virtual monitors is to use AR glasses to display floating monitors around the user, which would then allow them to take their office anywhere, from their home to a moving train. This idea has been envisioned for a long time, from academic papers to science fiction movies. But now we have reached a level of technological advances that gives us the opportunity to explore what that means for productivity work in terms of benefits, limitations, and new capabilities. So potential benefits could be not occupying physical space, being portable, and having any number of monitors, and potential limitations such as lower readability or a smaller field of view. So to investigate, we developed a prototype that displays Windows 10 through a HoloLens shoe. The three conditions we explored were physical, which had three physical monitors side by side, hybrid, that combined a central physical monitor with two virtual monitors on the sides, and virtual, which contained three virtual monitors. Important to note that the virtual monitors had 1.5 times the angular size of the central physical one, so from the perspective of the user, and were positioned at 2 meters depth to achieve a similar readability level and to reduce the accommodation version conflict, respectively. We investigated then two research questions. Our first one was to understand the limitations of virtual monitors when compared to physical ones, while we are considering the current state of the art. A second question was about the benefits of a hybrid setup that combines physical and virtual compared to a purely virtual one. We conducted a user study where 18 participants worked on documents to answer a report. We conducted in-person individual sessions of 90 minutes and investigated our three conditions, physical, hybrid, and virtual, within subjects. For each consecutive trial, we used a slightly different dataset to reduce learning effects, and we also counterbalanced the condition order using Latin square. Then we measured performance, accuracy, head and eye tracking, and also obtained subjective ratings on statements, ranking questionnaires, and we conducted a semi-structured interview. In the task, the participant they acted as a head TA, teaching assistant of a class, and had to use all these windows which are positioned across their monitors to answer a feedback form. Our results show that both virtual and hybrid are feasible approaches for conducting productivity work. Participants completed all conditions and achieved similar accuracy scores. This was reinforced by the individual ratings, where we found no statistical significance between I think I was able to focus on my work and I felt that I delivered a quality result on the task. So our first takeaway is that virtual monitors can be used now for real-world work, at least for short periods of time, using current existing technology. Going deeper, virtual is still less usable than physical, however. Overall, task time was 14% longer in virtual, which could be tied to a longer time to switch between monitors, as we also had 50% larger head rotation amplitude and 23% more accumulated head rotation. Users also had 20% less visual attention switches, which could be related to the smaller peripheral vision. Also, users were less confident in virtual, with worse order in the ranking. Individual ratings also showed they had less trust to do serious work and more difficulty glancing at the content. So a second takeaway is that there is a need for higher resolution and field of view devices, which could enable smaller monitors that require less head rotation. And as you can see in the graphs for task time and user ranking, hybrid acted as a middle ground between physical and virtual. We found that hybrid approximates virtual when there is more interaction on the side monitors, such as keyboard use, and it approximates physical when the task is more restricted to glancing at the side monitors while using the central monitor. Which leads us to our final takeaway, that under current technological limitations, it seems to be better to extend physical monitors than to switch to completely virtual ones. That happens despite the existence of mismatches between the displays, and one of the reasons is that a physical monitor next to a virtual one may reduce the effects of the lower field of view, as the peripheral vision can still be used. We got some good overall results, but there are still many directions we want to take in the future, such as how do these results change with higher resolution and higher field of view devices? What are the benefits of extending a single physical monitor with virtual monitors? What issues occur during long-term use of virtual monitors? And here we are especially looking into fatigue. And also, how can we take advantage of the flexible capabilities of virtual monitors, such as position, size, shape, and visibility? Thanks for your attention, and let's open for questions.